Now, I presume that most of you, since you're in this hall, are aware and interested in open source, free and open source software. And I'm also assuming that you are pretty much aware of the role of the community in open source. Now open source, and I mean free and open source in general is a mixture of many things. But the community is right up there as central. Although the programmers who create the open source or the free software programs, they are only one part of the community. There are actually much larger parts of the community, which we will see shortly. The point here is that the community is central to free and open source software. Now, you take any product, for example, or Mozilla. There is a core community, but there are multiple layers of communities around it. And the so-called open source or free software movement is a union of all these communities of different products which are there in the space. What is the role of communities? What do they contribute? How do they contribute? They contribute in multiple ways, right from design coding to testing to documentation to maintenance to support. Especially support, which is very crucial, because otherwise people do not know how. That's one of the early, as someone who's been associated with free software from the late 90s, one of the questions that used to pop up all the time was, who is going to support the software? And when we say community supports the software, many people were kind of reluctant. They were finding it hard to believe. But the fact is that today, this model is actually, well, very effective. Unlike paid support, I'm sure we are paying a small amount of money for the price that we are paying for MS Windows. But hardly ever, none of us use this thing. How many people have got onto the phone and asked Microsoft how to do something? No, nobody does that. But the community model works. The community owns the software and decides on its long-term strategy. And the community is important even if the free software product is created by a company. There are many examples of free software products being created by companies. For example, MySQL. It's created by a company. But still, the community is essential. But my point here is not the fact that free and open source software uses communities, but the fact that it goes beyond. We come to the question of open knowledge and communities. Now, what is really open knowledge? To understand open knowledge, we have to first understand knowledge, which in itself looks very isolated. But when you contextualize it, you must have seen this hierarchy. The data, information, knowledge, wisdom, truth. Now, this is a model that has been proposed sometime earlier, and it's normally called the DIKW pyramid, which looks like this. Many people consider truth to be out of this pyramid. But there's a reason why I'm including truth here. It's a little bit controversial. Because we will come to the reason why truth is here. But currently, we can think of knowledge as a part of this hierarchy. You start with data. You take the number 42. Now, 42 is a piece of data. It has no context. It is just a number hanging in isolation. But if you say 42 is the temperature intervandrum in degrees Celsius, then it gets context, it becomes information. That's something useful. Now, if you say 42 is the temperature intervandrum in the month of July, then that becomes knowledge, because then you start asking questions. How the hell has it happened? Because it's never happened. Trivandrum has never ever had a temperature of 42 in July, or for that matter, in any month. So we can start hypothesizing why has this happened. And wisdom comes when you attach something like climate change. Is this because of climate change that we are having this temperature in Trivandrum? Now, truth is when it is kind of immutable. Everything else is kind of negotiable. But when you come to the level of truth, it is something that cannot be changed. It is cast in concrete. And we will see why this is important. But we talked about open knowledge. So if you look at opening up, then you have open data. Now, open data is a big thing now. You must have heard about the Open Data Initiative, even of the Government of India. There are now data sets that are coming out. There is a site, opendata.gov.in or something like that, wherein you get access to these data sets. For example, I was playing around with a price data set, prices of commodities. It is in a format that is rather difficult to use, but it is very interesting data. Now, as civil society, we can then get this data. We can do things with it. We can ask questions. We can raise issues. It's very handy to have open data. And of course, the question is who's going to do this manipulation of data and ask these questions? It is us, the community. We move to open information. I'll come back to that in a moment. Open knowledge is what we started out with. Open wisdom and open truth. Now, what are some of the examples? In open data, we just talked about a data initiative. Now, open information is something that is very interesting to the scientific community because their business is to publish papers, to make available information to each other and to the world. Now, there has been a crisis in the publishing industry about 3 years back, and the net result of that is a movement called the Open Access Publishing Movement. Now, this is still in the kind of initial stages of growth. It has been happening for some time. The basic principle is that, especially when it happens to institutions which are funded by the government for research. Suppose you take any research institute in India, it is basically funded by the government. But if the output of this institution research is published in those journals which have a very steep access barrier, now I come from Italy. I think it's that you have to become a member of Italy, pay a lot of money, only then can you access the results of what the government of India paid for. That is a very contradictory situation. So if the funding is from the public sector or from the government, the information, the output also has to be with the public sector. And it should be open access publishing. This is the fundamental of open access publishing. And we have actually, it's actually a bit. Although initially there were some teething problems, there were some scams, etc. But today it is much more stable. When we come to open knowledge, the most famous example is Wikipedia. And I'm sure I don't have to Wikipedia to you because you're aware of it, and most of us use it on a daily basis. When Wikipedia came out in 2001, we were aware that there were many criticisms because people said, how can you expect the common person to write an article on an encyclopedia? That's a very skilled and technical job of editors who are especially qualified for writing in encyclopedias. So some of us said, look, it'll improve over time, but it's very important to have the public contribute to the encyclopedia because it will take out the biases. Otherwise, it's only the point of view of a certain bunch of people. Later on, as Wikipedia gathered and gathered more action, there were some problems, but overwhelmingly it has been successful. And we see Wikipedia, success of Wikipedia has resulted in a number of offshoots. From dictionary to, anyway, I don't get into this, but those are all examples of open knowledge. Now, open wisdom. I was reading the other day that there is a computer software which can now interact with a person and predict with about 80% accuracy if this person is suicidal. Okay, that's what a doctor would do, or a psychoanalyst would do. Interact with the person, talk to him or her, and then predict whether this person is prone to such a kind of behavioral threat. Now, this is wisdom, basically. Now, if machine language can do this, or machine learning, sorry, not language, machine learning can do this, then it is actually capturing the wisdom of people. Now, whether it's open or not is still an open question, because, some companies have proprietary mechanisms of capturing this, maybe neural networks, maybe other kind of technologies. There are also open libraries that allow you to capture these things. But in principle, we can actually today capture. We're not even talking about the BCI, the brain-computer interface, which can directly capture thoughts. That's a different thing. But here, there are methodologies whereby we can extract information from earlier used to be called as expert systems. So the expertise or the wisdom can be kind of gathered. I see that I have left out this open truth in this list. What would be open truth? What would be an example of truth? Maybe some of you can define what truth is. To me, it means something that is not changeable, something that has been established beyond doubt, and therefore open truth is something that is accessible to everybody at large, everybody who wants to access it. It is immutable. I'm sure you must have heard of technologies that can use to represent such a thing as immutable truth, or immutable facts even. And I would try to give you two examples. One is a blockchain, and one is something that you may not have heard of, Wiki Tribune. I'll start with that first. Now, one of the big problems that we're facing today is something called fake news. I'm not sure if you've heard of this fake news thing. There was lots of rumors that somebody was tampering with elections in multiple countries, including the US, and trying to influence the behavior of voters. And nobody was very clear about it. Some people said it's the Russians who are doing this. Some people said we do not know who is doing this. Maybe some anarchists who are trying to do this. Then what they do is to kind of provide or inject very realistic sounding news into the social media. And this gets reflected off the social media, and it gets kind of feeds on itself, kind of vicious circle. And after a while, people begin to believe that it is truth. And that, in India, of course, we have this thing of rumors over WhatsApp and so on. It spreads very rapidly, and it's very difficult to kind of stop these things. But fake news is the big problem because it is about the whole election. It's about influencing a whole democracy and its kind of movement or its trajectory. Now, people said this is something very bad. How do we counter this? How do we fight fake news? So, one of the solutions put forth was, why don't we have a bunch of journalists who examine these pieces of news, put out unbiased information saying that this can be attributed to something or it is completely fake news. And Wiki Tribune was an initiative started by none other than Jimmy Wales, who of course founded Wikipedia. So Jimmy Wales said, we have to fight this. And the way to fight it is to put together people, bring together people who are journalists, who can kind of figure out by tracing back the source of this information, whether this is fake news or genuine news. Tribune is an initiative where it's a funded for-profit initiative. They're going to raise funds, they're going to employ journalists, they're going to look at critical pieces of information as it comes out. And we can assume that once the Tribune puts out something, it is actually truth. So that's open truth for us. Now coming to blockchain. Now blockchain, we are pretty clear, you must have realized by now that the blockchain has several attributes. One of which is that it is immutable. One, it is append only. It's a data repository. I wouldn't call it a database, because a database is something slightly different and misleading also. Blockchain data is something that is append only. We can append things to it. We cannot modify anything that was there in the blockchain earlier. Now, how can we interpret the blockchain as open truth? Let's take some examples. Suppose I'm collecting information on automobile accidents in Kerala. Okay, and I'm putting on a website the date, the time, the vehicle or vehicles involved in this accident, their registration numbers. And over a period of time, I have built up a database, repository of all the accidents happening in Kerala. Now, don't ask me how I can get it. As of now, it is not very easy. Now, what is the utility of this information? Can anyone think of any useful thing that you can do with this? Yeah? Raising? All right, so that's a good use. If I'm a used car buyer, I'd like to know whether this car that I'm looking at now has been involved in an accident. Right now, there is no way. They can polish up the car even after the accident, even after a complete destructive accident. It's a way that we cannot make out. The end user, we as end users cannot make out. So if there was a database like this, then I could look up. Because I'm not saying fraud is not happening in this situation, because there are ways of apparently cannibalizing entire cars or changing the chassis numbers and so on. But by and large, we have access to a very valuable information that, okay, this car was involved in a collision. And we have some information about the daytime and the kind of collision it was. So we can imagine, okay, what would have been the damage. So what should be the kind of value. So this can be derived. And the problem is, if I am maintaining this database, at some point, I'm going to be in conflict with the second-hand dealer mafia. Right? So they're going to be very happy with my database. So they're going to come to me and say, look, they're going to offer me a bribe, saying that, look, some cars you change the data, you lose the money. Later on, they're going to threaten me and say that, okay, we're going to bash you up, we're going to take down your site. Because they're going to lose money by this. So what do we do? A website, a person individual running a website is a very bad idea, because that person is going to be under severe stress and pressure. The obvious answer is we do a blockchain. A blockchain is not an individual. Who has blockchain? Anybody who wants can have blockchain, a copy of blockchain. So that itself is the strength, that you can't simply shut down a blockchain by shutting down one node. The blockchain is distributed. It's got multiple copies. Secondly, even if you can influence a number of these owners and nodes, you can't change an old data in a blockchain. Why not? To understand why not, we have to figure out what is there in this blockchain that prohibits, that completely makes it impossible to change. The fact is that a blockchain is a linked list. Every record, a block is just like a page of a ledger. It's got multiple entries, maybe 200 entries on a page. Similarly, a block has 200 entries of transactions. In this case, 200 accident cases. Now, this entire thing is a block. And the first entry here is the hash of the previous block. Okay, and the next block that's going to come up will have a hash of this block. So it's a kind of hash linked list. The property of a hash, if you have studied hashes, a hash that extremely interesting things, and we'll see some examples of this, is that the moment you change one bit in any of this, then everything stops. Because the hashes will change. If you take a 1 GB file, make a hash of it, change one bit in that. Now, the problem is almost all of computing, including things like databases. Typically, a database has protection in place. But still, people have hacked into databases, which is why I don't want to call blockchain a database. Because the database can be hacked even given the privilege access rights. Because a hacker gets in with the right kind of controls, he can delete his own tracks, and yet he wants. And there is no copy of the data that we can fall back upon. So in this case, the system administrator, and in principle, there are ways of getting into that document once it is entered. The hashes make a very interesting contrast. Now just imagine what would be the case if we had e-rendering based on hashes. The first thing is, the tender document of each contractor who is bidding never leaves that guy's computer. Instead, what he does is he submits he prepares a tender document. In his computer, it's not even connected to the internet. He hashes that document. You get a hash, which is depending on the type of hash, maybe 128 bits or 512 bits, whatever it is. That is what he submits to the rendering process. His original document never leaves his computer. And one of the properties of a hash is that from any document you can create a hash, but you cannot do the reverse. It is mathematically impossible because it's many to a few mapping. If you have a hash, there are multiple original documents that can potentially result in this hash, which means you cannot go back from the hash to the original document. So what this man now submits in the e-tendering system is only the hash, and not the document, which nobody else has seen. It is in his own computer. And once you submit the hash, it is on a public website saying this is the hash, this is the person name. It's not a private doc. It is public. At the time of opening of the tender, they give the original file, and it is tested against the hash on the spot. And like we said, even if one bit changes, the whole hash changes. So you cannot fool the system. This is a much more efficient cryptographic system. Instead of right now, they've been trying cryptography on this e-tendering. It is very laborious. But this is a much more simple system. You can even see in public what are the hashes and what are the names of the people. And the actual document only reaches the e-tendering system on the day of opening. And even then, nobody can change it, because once you give a hash early on, you cannot change the document because the hashes will not tally. So it actually opens up a number of very interesting possibilities. One more example. Some of you might have heard this example. I've been using this example repeatedly. It is about the Internet of Cows. What is the Internet of Cows? Some years back, when I was in FOSS, we were looking at a project of enabling cows to tweet. What is the tweet milk production? How do they do that? They have on their necks a small tag, a passive tag, that's like a battery. The milking machine has a tag reader and the GK.
These cows they automatically go to the milking station in the morning and evening when they're in milk, and the station can sense the cow number. It can look up from its database which cow this is, and it also knows the whole thing is a Raspberry Pi control, small little thing. The weight of the liters of milk it can judge, and it tweets saying cow number such and such on this day, this time has produced so much of milk. And it's, of course, as a tweet is a public document. So technologically we found there's nothing very serious with this. We can always do it. But the question that we had is there any use for such a thing? Why should anybody be interested in such a thing? Okay, technologically it's possible, we can have a proof of concept, but what is the big deal? Can you think of any utility for this? So my friend who was with me at that time was in IIM Bangalore, and we were discussing it, and he went back to IIM, and then called me up a couple of days later, very excited. He said there are two sets of people who are very badly made of. So I said, who are they? The first was farmers. Now, why should farmers want this? For the same reason as second-hand cars. If I go to buy a cow, I see many cows in tweets historically will hold. There's no guarantee that a tweet will be continuously held in Twitter and shown to us when we search for it 2 years down the line, and it will be there. And depending on where you search from, the results are very different. We cannot trust Twitter. The role of a centralized, trusted, so-called trusted entity is totally meaningless. So the question is then where can we put this information? This is useful to people. Where can we place this information? Again, the answer turned out to be the blockchain. Now, if these farmers' organizations created their blockchains, and these things, instead of going to the Twitter, went directly to the blockchains. I mean, I'm not even getting into the whole consensus issue of creating these blocks and the whole proof of work, proof of stake kind of issue. Those are too complex to be handled here. But it is not insurmountable. The main point is that somebody has to pay for this. Maybe the farmers' organizations can pay for it, or maybe the bankers can contribute. But if you have a blockchain, this issue of a central trusted entity does not arise. Blockchain's main two critical advantages, according to me, one is that it does not require a centralized trusted authority. Number two, it can coexist in a network which has got many malicious nodes. As long as the malicious node do not control over 50% of the computing capacity of the network, blockchain has no problems. Of course, if the computing power is controlled by one entity which is malicious and it's got more than 51% or 51% or above, then you have a problem. Okay, so now I assume what you know, what we've been talking about as open truth, you're able to now relate to. There are a number of things coming here now, for example, voting, electronic voting, you think there is no evidence. So where the paper trail? So the paper trail you can have a blockchain.
Okay.
So there is actually evidence. And you can look up anytime. I can go and check my vote. Did the system capture my vote as I voted? So when you have a blockchain-based backing store, this can easily be done. And that's a very purpose of blockchain in the voting system. So open truth is actually very exciting. And the entire thing is exciting. My time is getting over. So let's move on now. So from open data to open access permission to open ledger, whenever there is something open, there's always a community behind it. In blockchain, in Bitcoin depends on community or these nodes. Without them, nothing will work. Bitcoin has a very clever technology plus social engineering parts, interlocked. And that's the reason for the success of Bitcoin. So the community is actually playing a very major role here. And it would be possible to consider some of these developments without the associated community. And for blockchain, the communities are radically important. Without the communities, the system will not work. Because you can't have consensus without the 2 or 3 kind of nodes. So you have a community. Typically in Bitcoin today, we have about between 6,000 and 10,000 kind of nodes, which are actively involved. Each of which hold the entire blockchain of Bitcoin. So now we have new disciplines, like for example, crypto finance or crypto economics. Now the fact is that the academic community, for them, this whole Bitcoin revolution is something that they had not anticipated at all. They are struggling, they are running to keep on top of this. This is developing so fast. So they have these new disciplines, crypto finance and so on. And they're studying the communities and their dynamics and their contributions to these things. The last bit of my presentation is about internet governance in communities. Now, internet, of course, is very critical to us. Whether it is open source, we create open source software, whether it's open knowledge or the blockchain, all of them take for granted that the internet is there. In fact, between Ethereum and Bitcoin, the main difference is that the time for confirmation in Bitcoin is about averaging 10 minutes. In Ethereum, it's about 15 seconds. Now, the problem in bringing down the response time, confirmation time, is that network latency. So, at 10 minutes, network is not a problem. Because even the slowest network can cope with 10 minutes kind of problem. Yeah. When you bring it down to 15 seconds, the network delays become very significant. So, in any case, we are taking for granted that there is this internet, which is there. And we have not even talked about it. All of us are individuals and even business governments and communities cannot function without it. But the fact is that still many of them do not know how this whole internet works. Who are the entities that make it work? Can we join those things? Can we influence the policy of the internet? So the fact is that it is actually complex. Internet ecosystem is actually complex. There is ICANN, ISOC, IETF, IAB, WCC, ITU. These are all various entities, and there are some more actually, which are involved in the managing both policy and day-to-day operations of the internet. But what we have not know is that almost all of this, except ITU in this list, all All the others are open organizations. And these are organizations that we can walk in and join. Of course, there's a huge learning curve. I'm part of ICANN and ISOC. And it took me quite a while to understand the language of this. And we need to probably move away from being passive users of these technologies to fully empowered community members. The community as a cloud. So when you think of Bitcoin, blockchain, and so on, we're talking actually about the community as a cloud. Now, I'm deliberately blurring the distinction between a human being and a node of the system. So Bitcoin introduced it, and Ethereum really took it to a different level, wherein the entire Ethereum system is one global computer. It is one computer. Nodes may come in, nodes may leave at their will. Not a problem. But still the state is main thing. So this is one huge global computer. It is a little kind of slow global computer. Slow because of so many other reasons. So this is a human cloud. Of course, the human cloud has been used in several different ways. For example, Uber is a human and a taxi car kind of a cloud. And the future of work, when you think of the way work is going to get transformed, tomorrow we're going to have carpenters, a cloud of carpenters. From there, we can farm out work into this cloud, and the cloud will take care of the whole management of the work. So the cloud will send a person to our home. He's part of the cloud. So that is the evolution of the human cloud. But human cloud is a community. And the whole issue of why did the open source take off? Why did even Microsoft finally had to move to open source at least for selected platforms? Because there's a fact called open innovation. And innovation cannot now be kind of bound by this so-called walled gardens. However big an organization is, we cannot confine innovation into that. Innovation is a global process. It's happening 24/7. And we need actually the community to do that, not a kind of a bunch of people, staff in an organization. And that's been the success of the whole network effect, wherein, I don't know if you've heard of Metcalfe's law, which says that the utility of a network is proportional to the square of the number of participants. So as the community becomes bigger and bigger, the utility of that community becomes proportional to the square of the number. And from the walled garden, we are moving to the bazaar model, where the community is actually in control. That's it from me. Thank you very much for the opportunity. And I'd be happy to take any questions. I don't know if we have time. We have time. Okay. Maybe 12 o'clock, so maybe one or two questions if there are anything.
Thank you. certain applications, like the collaborative applications that we have today, Twitter, LinkedIn, Facebook, all of these.
Social media?
Let's say social media, working in a blockchain kind of environment.
Right. So, see, the blockchain comes into its own strength when you have information that is immutable. When you have information that is mutable, requires to be changed frequently, a blockchain is perhaps not the answer. There may come a time when the blockchain can be used in that context, which is when it becomes time for information to be archived. It's no longer going to be changed on a routine basis. Then we can put it on the blockchain. The strength of the blockchain, now if you look at Facebook or any other centralized application, the security is centralized. Meaning Facebook has to manage its own security. And they have to try very hard because all the time the guys are trying to break it. And at times everybody has failed. Whether it's Twitter or Facebook, it's not actually
the least of which is the DDoS. Somebody is trying to distribute a service. I think it can fail. So, I would not advise.
Facebook itself, a backing store of a blockchain is very important. Facebook can use when the data becomes in an archivable kind of state, at which point they move it to the blockchain. But the real users of the blockchain are people or communities who do not want any central control. They do not want Facebook's policy to impinge on them. So they are the ones who will find most utility out of the blockchain. But of course, the banking system are already looking at the blockchain, but there's going to be a private blockchain, which is different from the public blockchain that we've been talking about.
Just one more question for again blockchain. So we say that in the blockchain we own the data, right? And we're talking about digital records and your areas where blockchain can be used. Please correct me if I'm wrong. I'm not an expert at this, but if you have a large file of data running device, you can hash it and have that hash tag stored inside the block. I think that's how probably it works. Do you see any infrastructure issues when you are trying to distribute? Currently, people, larger companies or organizations or governments, they have large data stores where a lot of this information can be stored. So what happens in distributed models where each of us has a node and want to store all of our data inside it and then hash it and link it to the blockchain? How do you see the infrastructure needs for this to be successful?
Thank you for that question, for both the questions actually. The point is that the Satoshi Nakamoto, who wrote the first paper on the Bitcoin, should actually look at the issue of scaling. How will blockchain Bitcoin scale? And he had compared it very cleverly with the Moore's law. He said this is the way capacity and computing power and storage is increasing. And this is how the Bitcoin is going to scale. So the Bitcoin is still okay. It is scaling okay. It will take about maybe a day to download the initial blockchain if you're having a node, depending on the network speed, of course. But if you look at Ethereum, Ethereum has actually gone one step beyond the Bitcoin. On Ethereum, like I said, it's a global computer. And you can, what runs on Ethereum is either your personal account or smart contracts. Suppose I want to transfer 1 lakh rupees to my grandson who's born in December on his 18th birthday. Okay, I can create a smart contract for that and put it on blockchain, put it on Ethereum. And 18 years from now, when my son reaches that date, Ethereum is going to transfer 1 lakh rupees, assuming it is going to 1 lakh rupees. And also, Ethereum, because it's a full, Bitcoin has a scripting language, it is not Turing complete. Ethereum has a scripting language which is full-fledged, it is Turing complete. If you have a Turing complete language, the problem in this case is that you can have infinite loops. Somebody wants to take on the system, you put an infinite loop. So Ethereum works with something called gas. So for every computational step, you have to make available some money. Only then your script will run. That is a protection against infinite loops. Otherwise, you can hack the system by having a program which is running amok. So they have thought about all this. They have thought about scaling. They have thought about how the smart contracts can be kind of, because they have blocks of code. And code can, unpredictable. Anything can happen in code. But despite all this thinking ahead, Bitcoin, Ethereum has faced a lot of problems. Last nearly 3 weeks, it is a gridlock. Nothing is working on Ethereum, and the reason was, of course, that there is hyperactivity. Too many people coming on ICOs. ICO is the initial coin offerings, like ICO. Too many things happening, and this is kind of bogged down, completely bogged down. Even today, it's not recovered. So scaling is a challenge. It's not going to be easy. So they have to figure out how to kind of challenge, how to handle this challenge. Maybe better algorithms, maybe better infrastructure, maybe a combination of all this. But people are working on it. They are aware that there is a problem in scaling. Unlike Bitcoin, which is much more slim, Ethereum is much more broader. It's an entire platform based on a blockchain. So thank you very much. Any more questions? Good.
This output data of
Sorry.
output data of deep learning by
There is nothing to stop us from storing anything on the blockchain. But the value comes by storing on the blockchain. Because there's a cost to this. You can put anything on the blockchain. But the cost can be kind of balanced if there is a value for it. So if there is enough number of users for this data of machine learning, then there is a value to, because there are also other kind of storages available for us. Blockchain is not the cheapest of storages. It's got a cost because of all this hashing thing and the number of copies that exist. So critical data we should maintain, like we talked about the used vehicles or the cows, milk production, etc. These are data that is useful for many people. So such data can be, it has a right to be based on the cost. So we have to judge based on the cost and the benefit, what should go and what should not. Thank you very much.
Thank you, Mr. Satish, for that eye-opener on free and open source software. I request Murli Krishnan from FAYA to present our token of gratitude to Mr. Satish Babu. Next is a session by Mr.